Hello all, I'm Sajid Ahmed from Kumaragur College of Technology and I'm studying final year at Electronics and Instrumentation Engineering. So in this video we are going to see how can we use Simcenter Amesim to use and simulate different systems. So this will be my presentation of my final project as a part of Siemens Digital Industry Software's student internship program. So we'll see with the video. So my title of my final project is design and validation of battery management systems. So okay, what is battery management system? Battery management system is the system deployed in the electrical vehicles to manage the conditions of the battery to maintain the ambient conditions so that we can keep the health of the battery at the required level so that we can increase the life of the battery as well as the working conditions and the ambience of the car. So the battery I focused in this project is lithium iron phosphate cell. So this technology is used in electrical vehicle industries because of its thermal stability and long cycle life. Cycle life means that you can charge and discharge number of times, and for this battery type it is comparatively higher. So the primary objective of the model I've simulated is to establish the control for the battery's charging with respect to two different parameters. So we'll see with the components used. So in SimCenter Amesim there are around 7,500 components for different domains like hydraulic, thermal, energy storage, and even aerospace, aeronautical, and you can deploy many of these components for different applications. So what I used in this project is battery packaging, and this component can be used to model different types of batteries. And if you have the parameters required for these batteries, you can deploy them. So that's the work of battery packaging. And the things which are in the square brackets is the submodel type. The submodel is a thing used in SimCenter Amesim for predefined values of different parameters which can be deployed to make use of our project. And the next one is control current source. This is used to charge the battery. Okay, so the thermal and co-management blocks involve a thermal mass and the convection. The thing thermal mass is used to capture the heat dissipated from the battery, and the battery is cooled by the air. For this project, so we are using a conventional air source to simulate the environmental heat dissipation. The next one is signal switches and constants. So the signal switch is the thing which connects the battery for charging and disconnects the battery after charging, and the constants are used to give the parameters which will determine the cutoff or charging. And the sensors are the devices which are used to measure the parameters. So we have used temperature sensor and a first order lag filter. So the temperature sensor is used to measure the temperature dissipated from the battery. And we'll go with the circuit, and if you see the left side of the diagram, we will be having K surrounded by a circle, and that indicates constants. The next, there's a relay kind of thing with four arrows, and that's the switch. And the next one is K by 1 plus tau s. It is a filter, and the T is temperature sensor, and CT is the thermal mass used, and the thing like spring to the right is the conventional air source, and the purple one with the cuboid is battery, and I is the control current source, and the last thing is ground. Okay, so the product has a battery. The battery is charged by that current source. So the temperature is being measured from the atmosphere atmospheric air, which is used as a thermal mass CT, and the temperature is given to the switch as a controlling value. So, if the temperature exceeds our parameter, it will stop the charging of the battery. Also, the battery's SOC, the state of charge, is taken as another parameter which you can see given to the second switch at the bottom, and we'll be having two constant, and if the state of charge increases or decreases that constant, the battery will be charged or discharged effectively. So this is a concept. The parameters used for battery pack is the battery capacity. So the battery capacity must not exceed 2.3 amperes hour, and the battery pack's initial state of charge is 10%. We are keeping the batteries initially charged to 10% and we have to charge to 100%. And the 100% will be 2.3 amperes hour. So all of the voltage sources, we see the battery is also voltage source. The battery contains the internal resistance of 0.005 ohms, and the current source will be having a charging current of 2.3 amperes, and this might vary with the different type of sources used. And the thermal mass is taken as aluminum because I didn't want to make the system complicated, so I just used aluminum with the value index 1. Index 1 indicates aluminum, and if there are n indexes, which is used to denote n number of materials. The thermal mass of the cell is taken. The thermal mass is used to simulate the mass of the air which gets the temperature from the battery, and it is taken as 0.085 grams, which is 85 kilograms, which is 85 grams. And the convective heat transfer, which is done from the battery to the air, is 15 watts per meter square per Kelvin, and the signal switch with the temperature as the constraint will be closing or opening above or below 45 degrees Celsius, and the signal switch 2 is the state of charge, and if that exceeds 100% or 1, which we have given as the constant, and it will cut the charging. The first order lag for delta time constant is 0.05. So what we have found from this system is linear state of charge progression. The upper plot we see at the left side indicates that the charging is uniform and the charging is cut off exactly at around 3200 seconds, which indicates that the charging has done from 10% to 100% at 3200 seconds. The lithium iron phosphate voltage profile mapping. The lower plot tracks the cell terminal voltage, accurately capturing the open circuit voltage profile of the lithium. So when we charge the battery, the voltage gradually increases, and it has increased from 3.25% when the charging is 10% to 3.55% when it is at 100%. And after that it is disconnected, which means the voltage has dropped to around 3.40 volts. So this is what we have found from the charging, and after that we can go to the safety control. This control we have deployed here is based on the temperature and the state of charge. The steady state charging phase. This indicates that the charger, which is the control current source, maintain a perfect 2.3 amperes of current for the charging of the battery. This is essential that because the charging current, if it is constant, will not affect the battery life. When it is fluctuating, it will surely affect the battery life. That's why in most of the cars there are different power electronic components combined to form equal amount or constant current. So between 3000 to 3200 we see minor oscillations. This is because the solver which we have used as a control system is having a high frequency numerical discontinuities, but this will not affect the battery that much, and we see that around 3240 seconds the charging has been stopped due to the attainment of 100%. And the next one is thermal profile. So the thermal profile indicates that when the battery is being charged, it gradually gives out the temperature, and we have seen that the temperature is not that much, and it has been maintained around 26 degrees, which means it will not have affect much of the battery's life, and the air is taking much of the heat away from the battery. So the internal heat flow of the battery is also being constant, which is around 0.3 watts, which indicates that this system can effectively control the battery's life and the battery's charging. So the key result is we have successfully deployed the control system for this battery and the safety tripping, which means when this battery is charged, it will gradually disconnect from the control current source, which is charging the battery. And this is how I have deployed my project. So I will talk about Simcenter Amesim as well as the Siemens internship. Siemens internship is given by Siemens Digital Industry Software, which is very helpful for you to learn about the Siemens softwares. When you're studying in college, it is very useful because you can learn the software, all the basic things when you are right at the college, and this internship opens the opportunity to work with the Siemens, and you can work with very highly talented professionals when you give your best for this internship. So if you get the opportunity, you can surely take part in this internship. And thank you for listening to this video.